99.8% of all the mass in our cosmic neighborhood. If you could gather everything, every planet, moon, asteroid, and comet, and pile them together, they would still be nothing compared to the sheer bulk of the sun. It stretches around an 866,000 mile across, more than 109 times wider than Earth. Over a billion Earths could fit inside it. And yet, despite its overwhelming size, it is just an ordinary star, one of billions in the galaxy. But how did it come to be? To understand the sun, we have to go back billions of years to the cold, dark past before its light first touched space. The sun was born in the chaos of a collapsing nebula, a vast cloud of hydrogen and helium left over from generations of dead stars. For millions of years, this cloud drifted in space, shapeless and still. Then something triggered its collapse, perhaps the shockwave of a distant supernova. Gravity took over, pulling the gas inward, compressing it tighter and tighter. As the cloud shrank, it began to spin, flattening into a swirling disk. At the center of this chaos, heat and pressure built up until hydrogen atoms were forced together, fusing into helium. This moment, nuclear fusion, was the birth of the sun. A sudden burst of energy erupted outward, a brilliant fire igniting at the heart of the forming solar system. The newborn sun blasted away the remaining gas with powerful solar winds, shaping the planets and everything that now orbits it. But the sun is more than just a burning ball of gas. It is the force that rules the solar system. Its gravity extends for billions of miles, a pull so strong that nothing within its reach can escape. Every planet, every asteroid, every frozen body in the distant edges of the system obeys its command. If the sun were to vanish, the entire solar system would dissolve into chaos, its planets flung into the void. Gravity is what makes the solar system a system. The sun's mass bends space itself, creating an invisible web that holds everything in place. This force is why Earth takes 365 days to complete its orbit, why Mercury races around the sun in just 88 days, and why distant Neptune takes a slow 165 years. Even Pluto and beyond feel its pull, their orbits stretching across centuries. The sun's influence doesn't stop with its gravity. It is constantly releasing energy, flooding the solar system with heat and light. Without this energy, Earth would be a frozen wasteland. Mars would never have had a chance for liquid water, and the outer planets would exist in total darkness. It is a cosmic furnace, burning through 600 million tons of hydrogen every second. A process that will continue for another 5 billion years. But the sun is not peaceful. Its surface is a boiling sea of plasma, constantly shifting, erupting with massive flares and solar storms. Gigantic loops of charged particles, known as prominences, stretch thousands of kilometers into space, sometimes collapsing in violent explosions. These storms can send blasts of radiation hurtling toward Earth, disrupting satellites, radio signals, and even power grids. And yet, despite its fury, the sun is stable, steady enough to support life, yet active enough to remind us of its raw power. Its light takes just 226 Earth days. If you stood on its surface, you would see the sun rise, slow to a stop, move backward briefly, then continue forward again, creating one of the strangest skies in the solar system. Mercury's surface is a battered landscape of craters and cliffs shaped by billions of years of impacts. The planet has no wind, no rain, and no geological activity to erase the scars of its past. One of its most famous features is Caloris Basin, a massive impact crater over 1,000 miles wide, so large it could stretch across much of the United States. When the asteroid that created it struck Mercury, the force was so great that it sent shockwaves across the entire planet, creating strange, hilly formations on the opposite side. Mercury's isolation and harsh conditions make it one of the least explored planets. Only 2 spacecraft have ever visited it. NASA's Mariner 10, which flew by 3 times in the 1970s, and Messenger, which orbited Mercury from 2011 to 2015. Messenger gave us our best look at the planet, mapping its surface in detail, measuring its gravity and magnetic field, and even confirming the presence of those polar ice deposits. But Mercury is just the beginning. As we leave behind this small, sun-scorched world, we move outward toward a planet wrapped in thick, golden clouds. A world even more hostile than Mercury, where the heat never fades and the air itself is poison. Ahead of us, a new world emerges. Welcome to Venus, the second planet from the Sun and the most extreme of the inner planets. At first glance, it might seem like Earth's twin. It's nearly the same size, with a similar rocky composition. But beneath its thick, golden clouds lies a world that couldn't be more different. Venus is the hottest planet in the solar system, with surface temperatures reaching 900 degrees Fahrenheit. Unlike Mercury, which cools down at night, Venus never gets a break. Its thick atmosphere, made mostly of carbon dioxide, traps heat in a runaway greenhouse effect, turning the entire planet into a suffocating oven. This atmosphere is so dense that standing on Venus would feel like being a kilometer underwater on Earth. And the air itself, it's filled with sulfuric acid clouds, making Venus not just hot, but corrosive and deadly. But Venus has another strange feature: its rotation. It spins backward compared to most planets, with the sun rising in the west and setting in the east, and it does so incredibly slowly. A single Venusian day lasts 243 Earth days, which is actually longer than its year, since it only takes 225 Earth days to orbit the sun. That means if you lived on Venus, a full day would last nearly an entire year. Venus has no large moons, no protective magnetic field, and no plate tectonics like Earth. Instead, its entire surface seems to behave like a single giant plate, with heat from the planet's interior occasionally building up and causing catastrophic resurfacing events. Without tectonic plates to slow release that heat, Venus may go through long periods of relative calm, followed by planet-wide volcanic upheavals that remake the entire surface. That could explain why Venus's crust is so much younger than Earth's. Despite the hellish conditions on the surface, there's been speculation that life, or at least something like it, could survive high in pulses with motion, oceans churn with currents, clouds shift in endless patterns, and lights flicker across the dark side as civilizations illuminate the night. It is the only planet known to host life, not because it is the only one capable, but because here, the conditions aligned perfectly. The habitable zone, the narrow band around a star where conditions allow liquid water to exist, is part of why Earth is so special. But location isn't everything. Venus is in the habitable zone too, yet it's a scorched wasteland. Earth's long-term habitability depends on many factors: its magnetic field, plate tectonics, atmosphere, oceans, and perhaps even the presence of the moon. Earth's own natural satellite is far more than just a pretty light in the night sky. It plays a crucial role in Earth's story. Formed in a colossal impact between Earth and a Mars-sized body called Theia, the moon's gravitational pull helps stabilize Earth's tilt. Without the moon, Earth's axis might wobble wildly, causing chaotic climate swings that could make life impossible. The moon also drives tides, stirring ocean waters and influencing everything from coastal ecosystems to global weather patterns. Leaving our home planet, our next destination is our potential future home, the red planet, Mars. Mars has been a source of curiosity for thousands of years. It's visible to the naked eye from Earth, glowing with a distinctive reddish hue that made ancient civilizations associated with war and fire. But the real Mars, the Mars we've come to know through decades of robotic missions, is both stranger and more fascinating than any myth. It's a planet of extremes, a frozen desert with vast canyons, towering volcanoes, and signs that water once flowed across its surface. Yet today, it's dry, cold, and seemingly lifeless. A reminder of how quickly a planet's fate can change. Mars orbits the Sun at an average distance of 1.52 astronomical units, meaning it's about 141 million miles or 227 million kilometers away, farther than Earth, but still relatively close in cosmic terms. In fact, Mars was the first planet whose distance was measured using astronomical units. Since astronomical units is based on Earth's average distance from the Sun, measuring Mars' orbit helped early astronomers refine their understanding of the solar system's scale. Grand Canyon is a scar. Valles Marineris is a deep, jagged wound carved into the Martian surface. But for all its extremes, Mars holds secrets that make it one of the most exciting places in the solar system. Billions of years ago, it was different. We know that water once flowed here, long, winding riverbeds, dried up lake basins, and even what might have been a massive ocean covering the northern half of the planet. Today, water still exists, but only as ice, locked away beneath the surface and at the poles. And where there was water, could there have been life? That's the big question. Rovers like Curiosity and Perseverance have been scouring the planet, looking for signs that life might have existed in Mars's past, or maybe even still hides underground. Mars's atmosphere is another mystery. It's incredibly thin, made mostly of carbon dioxide, and offers almost no protection from the sun's radiation. If you stood on the surface without a suit, the lack of pressure would make your blood boil in seconds. And because there's so little atmosphere to hold in heat, temperatures swing wildly. Warm enough in the daytime to make you think it's almost Earth-like, then plunging to deadly cold at night. Mars is a planet of extremes, a place where survival would be nearly impossible without technology. It has two tiny moons, Phobos and Deimos, small, lumpy, and likely captured asteroids. Phobos, the larger one, is slowly being pulled toward Mars and will one day crash into the planet or break apart, forming a thin ring. Deimos, on the other hand, drifts lazily in a distant orbit, a tiny rock lost in the vast Martian sky. For centuries, Mars has been the focus of human curiosity, the most Earth-like planet ever found, yet so incredibly different. It's also the most likely place for us to set foot next. Plans for human missions are already in motion, with NASA, SpaceX, and other space agencies looking at ways to send astronauts to Mars in the next few decades. It won't be easy, but if we can land there, survive, and maybe even build a base, Mars could become the first step in making humanity a multi-planet species. Mars is also the last of its kind, the final rocky world in the inner solar system. But before we reach the next planet, we must cross a vast boundary into something completely different, the asteroid belt. This region stretches from about 2.1 to 3.3 astronomical units from the Sun, or roughly 186 million to 370 million miles. This isn't a single structure, but a chaotic, scattered ring of millions of rocky objects drifting in endless orbits. It marks the dividing line between the inner rocky planets and the gas giants beyond. A boundary between two entirely different realms of the solar system. Despite its name, the asteroid belt is not a tightly packed field of tumbling boulders. If you were standing on an asteroid, you'd likely see nothing but empty space. The distance between objects can be hundreds of thousands of miles, making navigation through it far less hazardous than science fiction would suggest. But make no mistake, these asteroids are relics of the solar system's birth, remnants of a failed planet that never formed due to the immense gravitational pull of nearby Jupiter. The largest object here is Ceres, a dwarf planet with a diameter of 590 miles, the one that wiped out the dinosaurs 66 million years ago, have altered the course of life on our planet. Today, space agencies track these rogue asteroids carefully, preparing for the possibility that one might threaten Earth again. But the asteroid belt is also a potential stepping stone for the future. Many asteroids are rich in iron, nickel, and platinum group metals, materials that could one day fuel human expansion into space. Some companies and space agencies have even considered mining these asteroids, extracting water from rocket fuel, and using their resources to build future space stations. As we drift past the last scattered fragments of this ancient region, ahead of us looms the first of the outer planets, a world so massive that it could swallow every other planet, but still have room to spare. Now, we arrive at Jupiter. This giant planet is impossible to ignore. It dominates the outer solar system, a behemoth of swirling gas and violent storms, the king of planets. If the solar system had a second sun that never ignited, it would be this. Jupiter holds 318 times the mass of Earth, more than twice the mass of all other planets combined. It's a world so immense that its gravity shapes the orbits of comets, tugs at asteroids, and even influences its planetary movers. If not for Jupiter, the solar system would look completely different. It sits at 5.2 astronomical units from the Sun, about 484 million miles away. A world of churning clouds, Jupiter has no solid surface. Instead, it's a thick atmosphere consisting of mainly a hydrogen and 10% of helium, much like the Sun itself. Deeper down, the pressure crushes gas into liquid metallic hydrogen, a substance so bizarre that it behaves like an electrical conductor, creating Jupiter's mighty magnetic field. And with that, a dense core lurks, though scientists still debate its exact size and composition. Jupiter's most famous feature is the Great Red Spot, an enormous storm that has raged for at least 350 years. It's a swirling vortex twice the size of Earth, with wind speeds of 400 miles per hour, an unrelenting hurricane that never dies. Surrounding it, Jupiter's atmosphere is streaked with bands of color, white, orange, brown, created by jet streams moving in opposite directions at incredible speeds. These bands, called zones and belts, are made of ammonia clouds stretched across the entire planet by its rapid rotation. Jupiter spins faster than any other planet, completing a full day in just 9 hours and 56 minutes. That rotation fuels violent storms, chaotic winds, and towering cloud formations that reach 30 miles high. Beneath the storms lies an ocean of metallic hydrogen, covering most of the planet's interior. This strange liquid conducts electricity, fueling a magnetic field 20,000 times stronger than Earth's. It extends millions of miles into space, trapping charged particles and creating intense radiation belts. Any spacecraft that gets too close risks being fried by radiation stronger than the worst nuclear reactor meltdown. Even Jupiter's own moons have been scarred by this relentless energy. And then there's the gravity. Jupiter's mass warps space around it, pulling in comets and asteroids like a cosmic vacuum cleaner. It has deflected some space debris away from Earth, acting as a protector, but it has also redirected others toward us. extreme pressures, turning hydrogen into an exotic metallic form, generating a strong but less intense magnetic field. But it's the rings that steal the spotlight. Stretching 175,000 miles across, yet only about 30 feet, about 10 meters thick. They are made of countless ice and rock fragments, some as small as grains of sand, others the size of mountains. These rings aren't solid, but a vast, constantly shifting collection of debris, divided into 7 main sections, A to G. Each section has its own unique characteristics, shaped by the planet's gravity and the constant tug of its moons. The A and B rings are the brightest and most massive, densely packed with ice chunks that reflect sunlight brilliantly. The C ring is fainter and more translucent, contains finer particles, giving it a ghostly, almost transparent appearance. Beyond these main rings, the D ring closest to Saturn is so thin and diffuse that it's barely visible. Moving outward, the E ring is vast and diffuse, created by the icy plumes erupting from the moon Enceladus, while the F ring is a narrow, chaotic band constantly twisted and reshaped by nearby moonlets. And finally, the G ring, the faintest of all, drifts at the edge of Saturn's influence, a thin whisper of material barely holding together. But what's perhaps most fascinating is the Cassini division, the dark gap between the A and B rings. It's not empty, it still holds scattered particles, but its 2,920-mile wide span is largely cleared out by the gravitational pull of the tiny moon Venus, which orbits nearby. This division, along with many smaller gaps, shows how Saturn's moons act as celestial sculptors, shaping and maintaining the delicate balance of the rings. These moons, some embedded within the rings, others orbiting just outside, shepherd the ice and rock, keeping some areas clear while causing waves and ripples elsewhere. And Saturn has a lot of moons, at least 146 known so far. Some are tiny, barely large enough to be called moons at all, while others are worlds in their own right. The most famous is Titan, larger than Mercury, with a thick atmosphere of nitrogen and methane. Titan is the only place in the solar system besides Earth where liquid lakes and rivers exist, though they are made of liquid methane instead of water. Another, Enceladus, hides an ocean beneath its icy shell, spraying geysers of water into space, one of the best places to search for life. Despite its serene appearance, Saturn's gravity is a force to be reckoned with. It exerts 95 times the mass of Earth, holding its rings, moons, and even influencing distant objects in the solar system. Some asteroids and comets that pass through Saturn's domain are nudged into new orbits, sometimes flung into deep space, sometimes sent tumbling toward the inner solar system. As we drift away, leaving behind the golden glow and icy rings, we approach a planet darker, stranger, and full of secrets. Next, we arrive at Uranus. Uranus, a world unlike any other. It sits at 9.8 astronomical units from the Sun, nearly 1.8 billion miles away. It's the 7th planet, an ice giant, wrapped in a cold, hazy atmosphere that hides its mysteries beneath. Unlike its larger neighbors, Jupiter and Saturn, Uranus doesn't shine with swirling storms or towering cloud bands. Instead, it appears as a smooth, featureless blue-green sphere, its color coming from methane in the atmosphere, which absorbs red light its atmosphere lies an icy, slushy interior of water, ammonia, and methane, surrounding a small, rocky core. This is why Uranus and Neptune are called ice giants. They contain much more ice than gas. And even though Uranus looks calm, it's not. The planet has some of the fastest winds in the solar system, reaching 560 miles per hour. Like Saturn, Uranus has rings, but they are thin, dark, and faint, nearly invisible except when backlit by the sun. It also has 27 known moons, many named after characters from Shakespeare and Alexander Pope. The largest, Titania and Oberon, are icy cratered worlds, while others like Miranda have strange, fractured landscapes that hint at violent pasts. As we drift past this sideways world, we set our sights on the last great planet of the solar system, Neptune. Astronomical units from the Sun. That's 2.8 billion miles away. Neptune is a world of deep blue mystery. It's a true ice giant, similar to Uranus, but wilder, more dynamic, and filled with raging storms. Despite being so far from the Sun, where sunlight is 900 times weaker than on Earth, Neptune is anything but calm. Atmosphere, which absorbs red light and scatters blue. But this serene appearance is deceiving. Neptune is home to the fastest winds in the solar system, reaching 1,200 miles per hour. That's faster than the speed of sound on Earth. These winds whip through its thick hydrogen, helium, and methane atmosphere, stirring up massive storms. Famous of these is the Great Dark Spot, a storm similar to Jupiter's Great Red Spot, first seen by Voyager 2 in 1989. Though it later disappeared, other dark storms have since formed, proving that Neptune's weather is ever-changing. And with those stormy clouds, Neptune's atmosphere gradually thickens into a hot, dense fluid of water, ammonia, and methane. This slushy supercritical layer is similar to what's found inside Uranus, but Neptune's more intense internal heat may make it more active. Deeper still, there's likely a small rocky core about 1.2 times Earth's mass, surrounded by a mantle of hot ices and liquids under extreme pressure. Temperatures in Neptune's deep interior could reach 5,000 degrees Celsius, about 9,000 degrees Fahrenheit, hot enough to melt wasn't its size. After all, Mercury is smaller than some moons and still counts as a planet. The issue was its orbit. A real planet, by definition, is to dominate its path around the Sun. Pluto doesn't. It shares its orbit with many other objects in the Kuiper Belt, meaning it's just one of many icy worlds out here. So Pluto got reclassified as a dwarf planet, joining a growing list of similar worlds like Eris, Haumea, and Blackmailing. Even though it's no longer a planet, Pluto is still one of the most fascinating places in the solar system. It's covered in frozen nitrogen, methane, and carbon monoxide, and has a thin atmosphere that collapses and refreezes onto the surface as it moves farther from the Sun. In 2015, NASA's New Horizons spacecraft flew past Pluto for the first time, revealing a landscape unlike anything we expected. Towering ice mountains, vast smooth plains, and signs of possible underground oceans. It's a place where the surface shifts and changes, proving that even a world so far away from the Sun can still be alive in its own way. But Pluto isn't the only large object out here. There are other dwarf planets, each with their own mysteries. Haumea is one of the weirdest objects in the Kuiper Belt. It spins so fast that it's been stretched into an elongated, almost egg-like shape. It also has rings, making it one of the few known ringed objects beyond the gas giants. Then there's Blackmailing, which is covered in frozen methane, giving it a reddish hue. Its surface is so cold that even gases like nitrogen and methane freeze solid, forming a thin, patchy layer of ice. But these are just the big names. The Kuiper Belt is full of thousands, maybe even millions, of smaller icy objects that have never been explored. Some may be tiny, just chunks of frozen rock, but others could be undiscovered dwarf planets waiting in the darkness. Many of these objects follow strange, elongated orbits shaped by the gravity of Neptune, and possibly even an unseen planet lurking beyond the Kuiper Belt. The Kuiper Belt is also the source of many short-period comets, the ones that orbit the Sun in less than 200 years. Every once in a while, the gravity of Neptune nudges one of these icy bodies inward, sending it on a journey toward the inner solar system. When that happens, the Sun's heat causes the comet to release gas and